Anytime you measure something in science or in real life, there's always an error of measurement in your measuring. So you put something on the scale, you step on the scale in the morning, and it gives you a number. Every time you measure something, it has to round that number. So anytime that you're doing some type of calculation with those numbers, you have to take into consideration how many numbers you're starting with. Okay, and what that has to do with is something that are called significant figures. Remember that when we learned about scientific notation, we said we're getting rid of those unnecessary zeros. Okay, that's really what, when we talk about significant figures, that's what we're going to be doing, is we're going to be talking about the zeros that are not significant. So anytime we do some type of calculation, we're going to have to figure out how many what are called significant figures go into our answer. And to do that, the first thing that we have to do is we have to determine which numbers are significant, which numbers are not. Okay, because I'm going to give you numbers and I'm going to say how many of these figures, how many of these digits are significant in this number, and you're going to have to tell me. So there's some rules that I'm going to talk about, and then I'm going to try to shorten it so it's really, really easy for you. So here's a whole bunch of rules here. So all that we're trying to do is a figure, is one of the digits in the number, is it significant? Which, when we say significant, it means, do we count that number? Do we count it when we're counting up our numbers? Okay, so rule number one, basically, if it's not a zero, it counts. Okay, all non-zero digits count as a significant figure. So if it's not a zero, it's always significant. So the number 457 centimeters, the 4, the 5, and the 7, that has none of those are zeros, so those all three are significant. So you would say that the number 457 has 3 significant figures. Okay, the next one, 2.567, again, 2, 5, 6, 7, none of those are zeros, so therefore the number 2.567 has 4 significant figures. Okay, so really the rest of these rules are all about zeros. So the first type of zero that doesn't count is, think back to when we learned about scientific notation, when it was 0.0000153. Okay, and we said, why are those zeros there? Well, they're there so we know where the decimal point is. But really, are they important? They're not really, because we know we can write that number in scientific notation and it's fine. So those zeros, what we call leading zeros, or numbers or zeros at the beginning of the number, they appear to the left of the number, they are not significant. Okay, so the number 0.0003, none of these zeros here are significant. It only has one significant figure, the 3. Okay, 0.0195, again, has 3 significant figures, the 1, the 9, and the 5. Anytime a number starts with zeros, and you can see it right here in scientific notation, okay, same thing. 0.0000153 has 3 significant figures, and so does 1.5 times 10 to the minus 5th. Okay, when you write a number in scientific notation, it's just like you only look at the numbers that are right there, and yep, there's 3 significant figures. Okay, the time where that might confuse you a little bit is, instead of a 0 in the front, what if we have like a 5, like 5.000153? Well, now that's not a leading zero. It's not starting the number. Okay, a leading zero, the number has to be less than 1. It has to start with zeros. So these zeros now aren't leading zeros. Now we call them captive zeros. And a captive zero is one that are zeros that are between other numbers that are already significant. So the number 1005 has 4 significant figures. The number 108,006 has 6 significant figures, because again, the 0 right there and the 2 zeros right there are between other numbers that are also significant. Okay, so for right now, the only zeros you have to think about that aren't significant are, again, these zeros right here, when the number starts with zeros, when you have leading zeros. Okay? The other time that zeros don't count depends on what are called trailing zeros, and it depends. Okay? Trailing zeros that are to the right of the decimal point always count. Well, what the heck does that mean? It means 0.200 means that those are final zeros after the decimal point. They count. Okay, 3.0, that zero is a final zero after the decimal point. It counts. Okay. Well, what are some times when they don't count? Okay, if they're to the left of the decimal point. Okay, if you have the number like earlier, remember 25 million or something like that? Okay, again, the only reason those zeros are there is so you know that the number is 25 million. Is so you know the location of the decimal point is right there. Okay, 2.5 times 10 to the 7th. Okay, now, those zeros, when a decimal point is not written like this, do not count. They are not significant. Okay? But if you put a decimal point there, just like this, now you just made them significant. So like the number 100, the number 100 has one significant figure. The number 100 with a decimal point at the end has 3 significant figures. Okay, if you're talking about a 250 milliliter beaker, 250 milliliters has 2 significant figures. 250 point milliliters has 3 significant figures. Okay, so let me try to summarize all of that in just a couple of sentences. Okay, and it comes back to that example and that example. Instead of remembering these are when zeros count, these are when zeros don't count, just remember the 2 times when zeros are not significant. When you have leading zeros, the zeros are not significant. And when you have whole numbers, not after the decimal point, when you have a whole number here with no decimal point at the end, those zeros are also not significant. Okay, so in both of those cases, not significant. Other than that, they all are significant. Okay, and ask yourself, if I put this number in a scientific notation, does it do those zeros go away? If they do, that means they're not important. Remember, significant means is something important. You know, you talk about someone's significant other. That's someone who's important to them. Okay, these zeros and these zeros are not important. And when you put them into scientific notation, they go away. Okay, and so they are not significant. Okay, so here's what I want you to do. I want you to pause it at this point. I want you to try out example 1 and example 2, and then I'm going to go through each of them. So pause it at this point. For the first 12, tell me how many are significant in each, and then example 2, also the same thing. Okay, and then we'll check our answers and see how we did. So for number 1, 1,282, that has 4 significant figures. Okay, 0.00296 only has 3 significant figures. Those are leading zeros. Okay, the numbers starting with zeros, those are not significant. Okay, number 3 has 4 significant figures. Again, remember, if it's a whole number that ends with zeros, then the zeros don't count unless a decimal point is there. Okay, in this case, that's a final zero after the decimal point, so it counts. Okay, number 4 has 3 significant figures. Those are leading zeros, just like number 2. Number 5, again, the number ends in zeros, but it's after the decimal point, so it counts. So that's 5. Okay, number 6, none of these count. Those are leading zeros. That zero is between the 5 and the 9, and those are final zeros after the decimal point, so they count. So that number has 5. Okay, number 7, this is a whole number, but there's no decimal point. So there's our second example of when zeros don't count. Okay, those right there, again, I'm trying to kind of circle the ones, are when zeros don't count. Okay, so that only has 2. Okay, 10,200 with a decimal point at the end means they do count. So that one has 5. There's some leading zeros again, so that one only has 1. These are final zeros after the decimal point, so that has 6. They all count. 100 has no decimal point after it, so it only has 1. But 150 does have a decimal point, so all 3 of those count. Okay, letter A, a student's lab data results in 0.0105 grams of butane gas. How many significant figures are in that number? 3. Okay, the 0.0 are leading zeros, they don't count. Okay, and then letter B, a chemist records a volume of 0.050080 milliliters of vaporized water. Okay, those again are the leading zeros, so they don't count. All the other ones do. So 1, 2, 3, 4, 5 significant figures. And in an experiment, a span of time is determined to be 120 seconds. Again, there's no decimal point after that 0, so it doesn't count. So that is 2 significant figures.